Good afternoon and welcome. Do you have big data? Is there anyone in the room that would dare even raise their hand? Do you have big data? A poll of the audience here suggests that maybe 20% of you do. That is great. For those that either didn't raise their hand because they don't know, that's what this session's about. We dare challenge you that perhaps you do have big data, and this session is very much about opening your understanding and to inspire with you with what you could achieve with your data. My name is Peter Myers. I'm co-presenting with Saptak Sen here. Accent's American. Actually, I'm Australian. I spent a little too much time in America. I've been working in Microsoft Business Intelligence for well over a decade, and I'm very, very happy to be here in Madrid to present to you and share my knowledge and passion about Microsoft BI, and specifically how Microsoft BI and the big data story can play a role together. I've been a SQL Server MVP for the past 7 years. If you do need to contact me, I would suggest stick around after the session or catch up with me in the exhibition hall. Failing that, there are details here to contact or reach me on LinkedIn.
Hi, I'm Saptak Sen. I'm the product manager based out in Redmond in the SQL Server team focused on big data. Now, big data is a amorphous term. Specifically, I focus on HD Insight, Data Explorer, and some of the related technologies.
So the objectives for this session. To introduce what big data is, we appreciate there's been some foundation session this morning that has well described that. Maybe you missed that session. But really, we'd hope that you would leave this session with a good and clear understanding about what big data is, what is Hadoop, what is HD Insight, what are the processes involved in producing a solution that involves big data? And we're going to back that up with a variety of demonstrations. We have 5 in total that we're sharing between the two of us. And it's our intention and hope that this will inspire you with what you could achieve with your own data. Finally, we will wrap up with some resources that if you need to know more, we'll leave you with some links to continue exploring on this path. So let's start with the definition of what big data is. I think I found what I think is the best description on Wikipedia, and that is that we have data that is simply so large and or complex that it becomes awkward to work with by using traditional and conventional approaches, database management tools. Difficulties can include capturing, storing, searching, sharing, analyzing, and visualization. And very much this session then is to address, well, what can we do with these challenges? So big data solutions deal with the complexities, and you may well have heard of this, the 3 V's, starting with volume. Increasing volumes of data that we now can economically store presents an entirely new challenge. Yes, we can store it. The question will be, how can we do that effectively and efficiently? The variety of data. So it's not always conveniently tabular, that it fits into a table and therefore can be processed and queried in traditional and familiar approaches. The fact is that data comes in many formats. It could be Twitter feeds as text, could be binary data, could be XML. Finally, the velocity. The fact that this data is just pumping out quicker than we could even potentially store it in a relational database. These collectively are the challenges that could help us define that our data is in fact big data. It's a little bit nebulous what is big data, but I think if you use these 3 V's to help determine that that's what places it in the big data space. When we have a look here at plotting the volumes of data against the complexity, this variety and velocity dimensions that I've just introduced, these are no-brainers. We've solved these problems well over a decade ago. So your basic operational systems, inventory, sales, CRM, they fit nicely into the relational database story. As time has gone on, as technology has advanced, we see in the web that we've got web applications that are collecting even greater volumes of data. Web logs, for example, could collect literally terabytes of data about the activity that users have been doing on your applications. We could simply discard this information as not so useful, but because it's now economical to store this data, what we're waiting for is the opportunity to make use of that, to unearth or discover the hidden insights potentially in this volume of data. To take it to the current stage, what we will classify here as big data, here's the click stream, all sorts of what we refer to here as ambient data. It may be data that you're not intentionally collecting, but it's just being collected as part of a process or a byproduct of something else that's happening. We may have an e-commerce website, and sure enough, we store the orders in a sales system. But all of the related information about what people browsed to, what they clicked on, what they added to their shopping cart, what they removed from the shopping cart, there's hidden value in this. And this is the volume of data that you can collect, and we'll describe in this session how you can analyze it. We like this slide because it gives you an idea broken down by sector. So you may well directly relate to this, depending on your background, as to the data that you may be collecting, and that could be providing you these big data challenges. Most sectors are going to have lots of volumes related around text and numbers. But we'll see here, for example, in government and education, data coming in format of video and audio, whole new challenge about how we can deliver insight from this data.
Yeah, as you'd expect, in healthcare, if you look at it, there's a lot of X-rays and other kind of images that gets generated. Even the doctor's handwritten notes, you can't consider it text because most doctors are well known to have very bad handwriting. So they are captured as images and then converted into text. So
responding to a whole new set of questions, because these questions now can potentially be answered. Social analytics, what's the social sentiment of my product? What does the market really think of it? With live data feeds, how do I optimize my services based on patterns of weather, traffic, and other seemingly unrelated sets of data? And advanced analytics, how do I better predict future outcomes? And we'll definitely be presenting and talking and demonstrating about the data mining potential with big data. Introducing Hadoop. I think I'll hand this one across to Saptak.
Sure. How many of you have heard of Hadoop? I'm sure all of you, right? Yeah. So how many of you are already using Hadoop, playing with it, trying out something? Some of you. Just to kind of define a little bit of what Hadoop is. Hadoop is an open source project, and it's a conglomerate of projects. It's not just one project. The core Hadoop has two parts, the storage and the MapReduce, or the computation paradigm. Now, we're going to look at it more in detail and talk about some of the other projects, but the core thing is the distributed storage is one of the biggest kind of innovations around a distributed infrastructure. So Hadoop provides HDFS, which is Hadoop Distributed File System, which provides a namespace which looks to the application like a single file system, but it's actually spread across maybe hundreds or thousands of physical disk drives across a cluster of machines. So that's the storage part of it. Now, if you have such a distributed storage, your normal computation paradigms break down, because at some point you'll have to go over network and we'll have to synchronize, and thereby your normal computation paradigms of doing how SQL Server or other mechanism works, other query technologies work, those doesn't work anymore. So queries needs to be expressed as MapReduce, and we are going to describe MapReduce a little bit more in detail in a couple of slides.
And perhaps one of the most important parts of this slide, the cute little elephant. Why do we see this elephant come up every time we talk about Hadoop? Does anyone in the audience know? Yes. Right, because one of the founding developers that conceived this concept of distributed processing had a child that had a pet elephant that was named Hadoop. I can't actually understand why they named the project Hadoop, but whatever happened, it stuck. What's really fascinating about the whole ecosystem with Hadoop is just the novelty of the names that they use. As you'll see, we have things like pig and hive and so on. So it's sort of fun in this concept.
Right.
Talking about the Hadoop ecosystem.
Sure. So we talked a little bit about the Hadoop distributed file system, and this is the kind of the rock of the Hadoop technology, and it's based on a paper that Google wrote about their similar technology called GFS, which they used, and based on that, HDFS was created by Doug Cutting, and his daughter's name, or toy elephant's name is Hadoop, by the way. And then we have this thing called MapReduce. Now, MapReduce essentially means that you are spinning up a bunch of processes on machines where the data is sitting, and all these processes can run for a significant portion of the time parallelly without having to synchronize. Remember, in distributed computing, any kind of synchronization over the network is the enemy, is the nemesis of performance, of being able to get parallelization or efficiency. So MapReduce is designed in such a way that you have to express those queries in a way where it's, for most parts, is what we call embarrassingly parallel. If you don't like the word embarrassingly parallel, you can call it delightfully parallel. Now, of course, at the reduce part of it, you are basically doing aggregation. All the mappers, as we say in a MapReduce program, once they have finished doing what they do without having to contact each other, or in an embarrassingly parallel fashion, once they produce the results, the reduce part of it aggregates all that result. Obviously, that means that the reducers can't start before all the mappers have finished. So that means that those have to wait, and thereby a little bit of the parallelization goes away. Now, of course, raw MapReduce is extremely simple. I think of it as a brick, right? So if I were to build a house and somebody gives me a bunch of bricks, it's going to be a very hard task to go from that single brick to Burj Al Khalifa or whatever, right? So Pig and Hive provides higher level languages which help us express MapReduce in a higher abstraction level. So Pig is a data flow language, much like LINQ, and Hive is much like SQL. Of course, they are not the same as either LINQ or SQL. So they have their idiosyncrasies. Specifically, Hive, you'll see, while Peter does the demo and I do the demo, you'll see that at a very high level, it resembles SQL very closely. But if you go deeper into it, you have to understand that it is working on a parallelized platform. Now, we hear a lot about unstructured data, right? Hadoop is all about unstructured data. I think of it as Hadoop is for yet to be structured data, right? If the data cannot be structured, it's the cosmic background noise from Big Bang, right? The one that you see if your TV or your radio is not tuned into a station, you see either the ghosting or the static, right? So that is from the signal from the Big Bang. And that is unstructured data. Every other data, we haven't found time to structure it. So HCatalog, which was recently introduced, I would say, in the last year, provides that metadata, provides that repository of structure of the different data sets on HDFS. You have HBase, which is a columnar database. Then you have other libraries like for graph kind of computing. You have Pegasus. For machine learning, you have Mahout, which comes from a search index project called Lucene. And from Lucene, they carved out the recommendation engine to start with, and then other capabilities into Mahout. And then you have R Hadoop. R is a statistical language, and R traditionally was built for workstations, powerful workstations, which didn't need to depend on a distributed infrastructure. But R Hadoop is a project which is trying to port all those statistical libraries and algorithms to the MapReduce way of doing it. And of course, you can do all the processing and storing you can, but at some point, you have to consume it. You have to visualize it. And we are going to, again, Peter is going to talk a lot about it. I'm going to do a little bit of it as well. So you need things like ODBC, which we all know and love. You need things like Scoop. Scoop, here we didn't spell it wrong. It is spelled in the Hadoop world as SQOOP. It is meant to be scooping up data from one Hadoop cluster to other Hadoop cluster or Hadoop cluster to a SQL server. And the reason Scoop is important is Scoop runs as a MapReduce job. What that means is you can parallelly transfer in and out from HDFS a lot of data from either another HDFS or another structured data store like SQL Server. And then we have a REST-based API. The REST-based API, like WebHDFS, lets you directly interact with the data using a REST-based API, so that whether you have a .NET application or a Java application or you name it, if it has a REST library for it, you can go interact with the data directly. And on top of it, of course, all your existing business intelligence tools now can connect. And we are working hard to make sure this connection, this integration is as deep as possible. And you'll see some of that soon. And here are some other projects like Oozie. Oozie provides a workflow kind of language to do workflow around various MapReduce jobs and data management jobs. As you will see, to do even a most simple thing, a single MapReduce job won't be enough. You'll have multi-stage MapReduce jobs. And Oozie provides you that capability to do that. Flume is for log file integration, and Parallel Data Warehouse is a Microsoft data warehousing platform which integrates with Hadoop through a technology called Polybase. What Polybase gives you is kind of almost magical. It lets you use both the power of a parallel data warehouse, as the name suggests, and Hadoop-based infrastructure, distributed infrastructure, in the same query. So Polybase lets your query language, disambiguate on where your data is. It automatically goes and uses the right query engine to get the data from whether it's in the data warehouse or in Hadoop, and in the single query. So your applications actually don't need to change. You can use the same full power of Transact SQL or T-SQL that you know and love. So, of course, all of this is sitting on the infrastructure like, of course, Windows Server. It all connects to Marketplace, like Azure Marketplace. It is built on Active Directory System Center, and so on. So, what is HD Insight? You might have seen this term thrown around. HD Insight is just Microsoft's branding around 100% Apache Hadoop running as a service, fully supported and optimized service on top of Azure. So what does that give you? It gives you the power to quickly spin up a distributed infrastructure like Hadoop on top of the cloud without going through the craziness that if you had to hand craft a Hadoop cluster. It comes from the open source world. It comes from the Bay Area, startup world, where they can throw developers at every problem, and they have not the diversity of infrastructure in their organization that they need to support, and so on. So what we are doing here is to make some of these technologies which are amazing, which are very powerful, more enterprise ready and integrated with the infrastructure you already have in-house. And I'm going to talk a little bit more around when I'm doing the demos. I'm going to point out some of the aspects of it. So
over to me, how it works. I think it's time to actually dive into a demonstration. We'll come back to how it works.
Sure.
And I'll explain why we're taking that strategy. So what you see before you is the dashboard for HD Insight. What's different between the demonstrations that I'll do and that SAPTAC will do is that I'm using HD Insight Server. This is really designed as a sandbox for you to work and test. Once you really deploy and you're working with production big data, you'll be talking about Azure HD Insight. So what I'm doing is slightly different, although the interfaces look almost exactly the same. The Hello World example for big data is the word count example. I'm not sure if it has a truly real-world application anywhere, but this is how the demo goes. And it allows us to go through the basics and show you the mechanics of what happens when we produce and then query the solution. The interactive console here then allows me to work with two different languages. There's JavaScript or there's the Hive that SAPTAC's already introduced. And what I'm going to do is just point out that there are a whole series of commands here. I'm not going to go through every one of them. I'm going to go ahead and list from a directory that's already been created that I've got a file here.
You might have spelled it wrong.
Berg. That's it. So there's a single file here. It's a book known as Da Vinci. It's got lots of words in it. And it's a very, very simple demonstration. So with the recognition that I already have this file on the file system, what I'm going to do then is upload a script which is basically the map reduce logic. Oops. That's exactly not what I was supposed to do. Demo folder, assets, and the word count JavaScript file. Go ahead and upload this. It's now part of the file system, and let's just take a look at what it looks like. Sorry, it's a little dark up here. There's two methods. The first one here you'll see is the map method. The second one is the reduce method. So bear in mind that the map would be distributed across each node and would be responsible in parallel for doing its part of the query. And then what happens is the results of all of these map jobs get reduced via the logic that's contained in here. Now, I'm not going to go through what the logic is. Essentially, it's counting words, collecting statistics. The reduce then goes ahead and aggregates all of those counts to provide the final query result. So with the recognition of that's the logic that I have, then what I'm going to do is use pig, and here is a snippet that using this command here, using the map reduce logic that I just uploaded, I'm going to go ahead and count all words and in descending order retrieve the top 10 into this file here. Okay, and the job is off and running. And you can, if you're very patient, sit here and watch the fact that it's running. There is a log file here that's accumulating all of the processes that are going on. So if you can think in a real-world example, there could be literally dozens, if not hundreds, potentially thousands of servers where the data is stored, and this map job is being sent down to all of them. And independently, they're doing their part on the data that they have access to. And at some point, they then contribute their result back to the reduce node that brings the result together. Now, switching back. What's really going on here then? So how it works. First, store the data. That data has already been stored. In this demonstration, it's a single file representing the contents of a book. In the real world, it's going to be numerous files, be them web logs or so on. Second, take the processing to the data. And you can see here on the right-hand side, there's our map reduce functions written in JavaScript. Takes that code, sends it down. Each node then is processing in parallel. And this is where you get the true parallel behavior and the scalability. And then the result will come back as a reduced job. The result then can be consumed and represented in a way that makes sense for the analysis that you're doing. So that leads us into this first demonstration. Let's take a look at where it's got to. Still processing. You'd think that this is rather excessive for such a small file, but that's just the process it needs to go through. Remember, this technology was designed for larger volumes, not just a single text. How long do you think a business user is prepared to wait when they issue a query for that response to be returned?
No.
10 seconds? More or less? More. They're prepared to wait 15 seconds for that response to come back. You know, I've been teaching business intelligence for well over a decade now, and I used to use the statistic of somewhere between 5 and 8 seconds. Because within that time, if the response hasn't come back, they're obviously distracted, context switched to some other activity or task. They may even forget that they issued the query, or more dangerously, by the time the query result comes back and there's switched context to it, they may well misinterpret the data because they've actually forgotten what the original request was. What's interesting today is that that statistic is generally regarded to be somewhere between 3 and 5 seconds. That if your system does not respond in that time, user has given up, doesn't trust the response, or even forgets that they even made the request. Now, the fact is, this job is still processing. So this is what introduces the dilemma for us, is that when we've got all of this insight in the big data, the challenge for us is to make sense of it, make that big data small data, but also to make it responsive. All right, so just bear that in mind. I think we're 90% complete. We'll be addressing this by talking about how the Microsoft BI stack can fit on top of big data and how the features built into the stack can support pre-caching, snapshotting of data in advance so that we get high response times back to our users. I like this word. We have success. So still in the JavaScript console, what I can do with this is create a variable here that is going to read the content of my file. Da Vinci top 10 words. Am I still misspelling something? Maybe the capital R isn't good. There we go. All right, so now that I've got the top 10 words, we can see in descending order, as our request was, that the is the most common word. If I go ahead and parse this, so take that file data and parse it into the word.
Spelling again.
I'll fix that up. Sorry, it's dark here. I can't see my keyboard. There's no light. So I'm going blind when I type. Data.parse. Thanks, Saptac. And another one. All right. And it doesn't like that. Data equals. Okay, I usually do snippets, but I thought I could type it fresh this time. What we see here are the key value pairs that are being returned. For each word, we have a count corresponding to it. The last thing I can demonstrate here to make it look a little more attractive is that we can take that data and represent it as a bar chart. I mean, that's basic analytics. We would not expect our business users to come in and to perform that type of analytics using that console.
But think about it from data scientist perspective. You'll hear this word thrown around all over the place. So what is the role of a data scientist? A data scientist is typically a person who has deep domain knowledge and a deep statistical background. So what he can go do is you can unleash him into the raw, unprocessed data, and he can dig around and figure out what can be extracted, what value can be extracted for the organization. At that time, he doesn't need something fancy or cute. He just needs to kind of muck around. And this kind of tools are what's going to give him the environment to interactively muck around with the data.
Okay, so the traditional e-commerce data flow. Let's take a look at the operational data that you have. Collecting all sorts of information. Product data, the sales data, CRM information, all fairly standard. And the standard approach has been that we periodically extract, transform, load into a data warehouse, and this becomes the analytic and reporting platform that we move forward with. What do we do with the byproduct data, those web logs on our e-commerce server? Well, the traditional approach is that we might extract some value from them, but typically we find that that data just ends up getting permanently archived, i.e. trashed. The fact is, though, that there is value in that data. Those log files could be stored on the Hadoop file system, and then we could ask more interesting questions of that data. We could mine for information. We could analyze for subtle trends that might appear across this vast sea of information that's being collected. And then we could analyze from it. We could also ETL from this into our data warehouse. And that leads really nicely into the next demonstration about how we could just ETL from the data by using Hive. Right, so back in the console. This time, I'm switching across to show you Hive here. And I already have created a Hive table across a series of weblog files. So I can show you the definition here. My table is named weblog. So basically, this is a metadata layer on top of some CSV data. And what this command is telling me is that this table represents in total 4 files. There could be literally thousands of them, but for demonstration, it's been kept small. And the definition of the table is really a collection of columns with data types. So Hive makes life really easy for us because we can go ahead and query this by using SQL-like constructs. Here is a Hive query that is going to extract from the weblog table a series of columns, a where clause that will filter out just the particular information we're interested in. In this case, requests to the browse page for the year 2008. What happens with Hive then is that query is being sent and implicitly MapReduce jobs are being created. You don't have to create that JavaScript. You just come up with a valid Hive query on top of the data and then consume the result. Okay, so this result is going to take a little while as well, with appreciation of all that's going on under the covers. There are literally thousands of weblog entries. Now, the intention of this demonstration is then to switch across as an ETL developer using perhaps familiar tools like SQL Server Integration Services and to ETL from this result. Okay, so what we can see here is just the first 20 kilobytes of data result, and this took 32 seconds to execute. So this is my HD Insight server. I'm now switching across to my development machine. And so the first thing that I'm going to do here is come into Management Studio, and I am going to run a script that creates a new fact table to store weblog information. So essentially, this is going to be my weblog table. Now, in order to connect to Hive, Microsoft have made available an ODBC driver that we can install to allow us to connect and to issue commands to the HD Insight server. So I go ahead, very simple, accept the licensing terms, install. I can then go ahead and define an ODBC data source using the Hive driver. So we provided a name and the server name. Now, there's no authentication that I would configure here. That seems really odd. We would typically want to protect our data. But in the preview version that I have available here, there is no encryption or authentication. So just accept that that's the case in preview.
We'll take care of that. Don't worry about it.
All right. So I'm now switching across to Visual Studio. I have an integration services project. And here I have a project connection manager that has been configured to connect to the HD Insight server. And then here in my package, basically the parameterization is asking what year or what day are you extracting from, and then it deletes for that year any existing rows. It then uses a data flow task here to extract by using an ODBC connection manager using Hive, and then transformation of the data to get it into the right state and load it into the data warehouse. And essentially, that's the demonstration of how you could then consume your big data. Clearly, if it's truly big data volumes, you'd be doing things like aggregating, filtering, to make that big data smaller data, something that would be useful to then store in the data warehouse for ongoing analysis. Okay, that's going to take about 33 seconds to execute. I don't think we need to see the end of that demonstration.
Yeah. By the way, one of these tasks could also be you trigger off a scoop job, which moves the data parallelly over to SQL staging area.
Okay, the Hadoop data flow. Over to you, Saptak.
Okay, so it's a very simple, illustration which shows that at some point you have raw data, a lot of raw data, and the master data set, if you may, sits in a distributed storage like either the Azure Blob Store or HDFS. And then you use Hadoop to process it, to extract the entities that are interesting to you. And then finally, you want to stage it to be able to interact with it and visualize with it. So one of the aspects that I wanted to point out was we talked about HD Insight Service. Now, HD Insight Service is built on Azure Blob Store. It can automatically mount your Azure Blob Store where you might be storing all your data from, if you're running mobile apps on Azure, they're creating logs. If you're running other web services, other things, that might be creating some kind of what we call the ambient data, and that might already be sitting in the Azure Blob Store. Hadoop, you spin up a Hadoop cluster, you process it, you store the results back, and then you can shut down or destroy the Hadoop cluster. So how many of you watched the keynote this morning? Yeah? Yes, most of you. So we talked about how we are doing some of the things where we can bring down your cost of operation on Azure significantly. This is one of them. You don't need to pay to have a distributed infrastructure like Hadoop up there when you are not using it. You bring it up, use it to process it, and then it goes away. But your data needs to live on, and your ability to consume that data needs to live on. So that's what we were going for. So with that, we have a demo. So let me unlock my machine. So okay, let's wait for it to switch. Not that one, 6. Sorry. Yeah, there you go. So here we have Azure Portal, right? This is just plain sim. And if you have visited Azure Portal recently, you'll see this new thing called HD Insight. In fact, if you go to new data services, there is HD Insight with a small preview written because it's in preview. You can create a cluster in under 15 minutes of a size of your choice on Azure. Now, I already have a cluster running. So if I say manage cluster here, it will take me to an interface which is very similar to what Peter showed you. So this kind of absolutely looks like what Peter showed you. And so the great thing is that you can build and test your application on that developer sandbox cluster, one-node cluster that he's running from his laptop. And then once he's tested this application, he can run it on Azure. Now, let me go inside and actually show you the data. The data I have is, I'm going to use the similar commands. The only difference is you'll notice that I'm using this handler called ASV://. The ASV:// basically means get me the data from the Azure Blob Store that is mounted from this Hadoop cluster. So I have here about 30 years of stock tick data from New York Stock Exchange. Now, that could be a lot of data, and thereby I want to process it on Hadoop, as Peter said, make big data small so that I can start consuming it and visualizing it. What humans are bad at is looking at big data with their bare eyes. So they need tools like Hadoop, which can do parallel processing on this data and make it manageable so that they can make sense with their eyes. So here is how we kind of make sense out of it. So you saw the Hive console. So what I'm doing is, with this, I'm creating some Hive tables on the raw data. So I can go to here and, oops, I'm clicking too fast here. Just give me a second. Interactive console and Hive console. So I can go do this, and I'll say NYSE price is 2 because I might have already created this, and I say evaluate. Now, at this point, what it's doing is it is creating a metadata entry in Azure database, and you don't need to know that, actually. And it's just doing that. It's not touching the raw data. It's just creating a schema which will be used later when we use the query. So we can do a similar thing on the prices. For the lack of time, I think we are kind of running a little low of time. So we can create a dividends table similarly, which I already have done. And then what I'm doing is I'm creating another table where I want to aggregate the data. The data is that every stock tick, every stock tick, what's the price, and what is the dividend, right? Now I want to aggregate it up at a year level. At a year level, I want to know what is, for a particular stock symbol, what is the average price, what is the highest price, what is the lowest price, and what is the dividend. So in this particular query, if you see here, that's what I'm doing. Here I'm doing a join between the dividends table that I created, Hive table, and the prices table that I created on the raw data that I created here and here, and I'm doing a join and insert into this stock aggregates table which I just created. So what that does is that spins up the MapReduce job like Peter showed and aggregates the data and drops it into a folder. For example, I can run this query. It's going to run the job for some time. Copy, paste, and I can call it aggregates 3 or whatever. I have been practicing. So this will spin up the job. But in the meantime, not to wait for this for very long, okay, I didn't define it, so I need to use the same name. Yeah. So it will go and do the job, but in the meantime, let me show how do I consume the data. So I'm going to come here and I'm going to start Excel. Now this is just plain vanilla Excel, and I have a blank worksheet here, and then I have Data Explorer. Now Data Explorer is a capability that we released in last February to discover, consume, shape, and feed it into a model. That's the capability. Now as you can see, I can connect to many different data sources from here. But what I'm going to show here is to connect to the Azure HD Insight cluster that's running for me in the Azure. And again, given the bandwidth, I don't know how fast it will go, but I'm going to anyway do it. So now it's brought up all the data on my Azure Blob Store. At this point, I no longer need the cluster because this is picking up the data which has already been persisted by the Hadoop cluster. So my data that I'm interested in is this one. And as you can see, every time I run, it creates that output. So I'm going to pick one of them, right? So here I've picked up the data. Now I'm going to go do a little bit of structuring on that data. With a single click, I've got a structure on that data. So as you can see, the first one is the symbol, year. For every year, we have one record, and then the high, low, and the average. I'm going to drop the high and low for practical purposes. Means in this particular demo, I won't use those. I'm going to rename this to symbol. Okay. That works. I don't care what exactly it's renamed to. Year. And this is my price. I'm losing the first letters always. And this is my dividend. Okay. Now, I see that this data is, I need to kind of clean up a bit, because for the years that companies didn't pay any dividend, it's showing up as /n. It's not in the form that I would like. So I can very quickly go and say replace value /n with 0. That means they didn't pay any dividend. And it's doing it, it's basically writing a program on the sample of the data, as you can see. Once I'm done with it, when I say apply, then it's going to apply on all the data. Now, this is still a lot of data. I don't want to do this analysis on all the data. Who is from United States here? I have a question for you. Anyone? You? No? Okay. So Peter, you have stayed in United States for quite long. So tell me, which are the stock symbols in S&P 500?
I know Microsoft is MSFT.
Microsoft is in NASDAQ.
Oh, NASDAQ. Okay, I don't know then.
In S&P 500. Okay. So we are going to look it up. Since Peter can't give us that information, I'm going to go do a search on the interwebs, as I like to call it. At this point, what I'm doing is I'm going to the internet to get the part of the data that I don't have in-house, right? And I'm going to merge these two data. So it's pulled up a bunch of data. I can preview what data these are. And I'm going to click on one. And so it's brought me that data. Now, what I'm going to do is I'm going to go merge the two data. So I'm going to say, go to Data Explorer and say merge. Now, this is my proprietary data based on what I had on Hadoop. And this is my data from out in the world. I'm going to do a join between these two. And I'll say, OK. As you can see, it's brought down the data. Now, the additional columns that I want are, I already have the ticker symbol. I just need the company name, the industry they are in, where they are headquartered, and that's about it. So now, with a few clicks, I've got additional information like, what is the name of the company, what is the industry they are in, where they are based out of. Now, you will see that some of the records or some of the rows here have null. Any idea why that's so? Because they are not part of S&P 500. So very quickly, I can filter that out. Boom, right? So now I can set the right data types. Now I've got the change type to number. This price is already changed, is in number format, and that's good. Now it's going to apply that. And at this point, I can, it's applying all the things, and it's going to download it. OK, it's almost there. Here. And if I press load to model, this is the Power Pivot model we are talking about. and attend Peter's session tomorrow to know about more
We're
about
deliberately
Power.
avoiding Power Pivot in this session. We have an entire topic tomorrow that I present on big data analytics with Excel and Power Pivot and Power View. And so we're going to step over it in this session, but please, if you want to know more and a recap on some of the big data topic that we covered today, there is a session dedicated to it tomorrow.
So now I'm going to do something fun, right? I'm going to map it on GeoFlow, right? So here's my GeoFlow. Here is my headquarters that I'm, and this is the I guess the city, yeah. And I say map it, and I have to rotate it to show the United States. You can see things started showing up on the United States. Now I want to, so dividends, let's say, I want to do an average of the dividends. So with a few clicks, now I can find out, I want to invest safely, so I want to only focus on S&P 500 stocks. So that's why I limited my analysis to S&P 500. And now I know where to invest, based on where. So with that, back to...
That's the end of the self-service BI story, is it?
Yeah.
Okay. Self-service BI with Hive and Data Explorer, Power Pivot, GeoFlow. Okay, so next topic is to start exploring the predictive capabilities. So the data mining capabilities that we can work with big data. We've already looked at ETL. I've given you an example with integration services. PIG is a topic we could talk about in much more detail that could accommodate ETL requirements. Distributed compute, we've talked about this. We're heading into the area of predictive analysis, machine learning, and graph processing. So there are a whole suite of algorithms, and we could talk about each of these perhaps in a dedicated session, but this session doesn't really allow us to delve so deeply. So we're going to focus on frequent item sets, is one that I'll give you a demonstration on in a minute. But just to look at the potential here with your data, if it's social networking data, discovering value about connections and relationships within social network data, targeted advertising and being able to understand customer need through weblog analysis and clickstream analysis. Let's take a look at the frequent item sets example. The most common would be, if anyone has navigated to Amazon before, you're browsing on a particular book, what do you see? Those that bought this book also bought these books. How does this happen? This is market basket analysis. Adaptations of frequent item sets could also be looking for similar items like plagiarism. How do we know that this text document is similar to this text document? So they sort of all come under a very similar discipline. Let's take a look at a demonstration of analysis services data mining with Hive. There's the result of the integration services package that executed. We see success. We see that we've populated the data warehouse. Thank you very much. Close, move on. So what I'm going to do is introduce a second project into my solution that will be an analysis services multi-dimensional and data mining project. Weblog mining. Now, analysis services for multidimensional only works with OLEDB. And as I introduced in the previous demonstration, is that the connectivity that we have is ODBC. So the way that I can work around this is create a linked server and have SQL Server using the OLEDB provider for ODBC connect via that driver. And then I'll expose the big data through SQL Server views. This is how I would do it. Come in, create a new linked server, provide it a name like HD Insight, choose the OLEDB provider for ODBC drivers, and then specify in the data source the name of my data source name. Then I can go ahead and I have a script here to create some views. So you'll see here it's using the fully qualified name of the linked server right down to my Hive table. This gives me the distinct sessions, Here it gives me the models that were browsed at the same time within a single session. So the problem that I'm solving here is we want to identify what models people are browsing at the same time. So I go ahead and run this script that will create 2 views, and now I can use Analysis Services Project to connect and query, and therefore consume the big data and then data mine it. So in this project, I define a data source that connects to the data warehouse. Configure it to use the service account credentials. Don't do this at home. This is what we do in demonstrations. Best practice would mean use fixed credentials. The data source view is the next step. So what I do here is I'll introduce both of those 2 views. Add them across into the data source view. And this is how the big data surfaces. Come up with a little more friendly names. This is just the session. This is the basket, representing the models browsed within the session. Just add some logical keys here that they are unique combinations, and create a relationship here that shows that a session has multiple models browsed within it. I can then go ahead and create a mining structure based on this data source view that uses the association rules algorithm. This is the algorithm for market basket analysis. Using that data source view, the session being the case, and nested within it is the basket of models that were browsed within the single session. What I'm looking to do is predict the models within the basket. The data types and content types are fine. Don't need to reserve any data for testing, and I come up with a name for both the structure and the mining model. Now that creates the mining model. There's one tweak that I apply here, and that is the algorithm parameters. I want to make this a little more sensitive. And so I reduce these parameters that guide the algorithm on how to do its job. And now with that in place, I can deploy this project that in turn creates a database on my instance of Analysis Services, defines the objects, and then processes. So at this point now, it's querying the big data. And as you now appreciate, that big data is creating MapReduce jobs, distributing it across all of the nodes within the cluster. The result comes back, and then Analysis Services, as a subscriber to that data, goes ahead and mines it. We have success, and then we can go ahead and use the visualizations, like the dependency network here, to then understand the relationships. So for example, we're interested to know about mountain bikes, the Mountain 200. And then we can learn from this that people that browse this are also browsing these. And then we can understand the strengths of the relationships across these. And here's value that we can then gain from the browsing activity, not necessarily the purchasing activity. That's reasonably straightforward because our sales systems will be capturing this. But here's a more subtle analysis of what people are actually looking at but not necessarily buying. I think that's as far as that demonstration needs to go. That was Analysis Services data mining. Just to be clear there, my 2 demonstrations, because I'm a Microsoft BI expert and that's what I've worked in for the last 10 years, I see in these examples that big data is just another data source. I can ETL from it. I can continue to build data models, data mine direct from the big data source.
Yep. Okay, so I'm just setting up for the next demo. Now, what Peter showed you, 95% of the organizations that need predictive analytics or data mining this is absolutely adequate. But in case you are the Amazon of the world or the, I don't know, CD Baby of the world, and you want to do data mining on big data where you have, say, hundreds of terabytes of data, how do you do that? You need, again, a distributed infrastructure. So we can do big data mining on this kind of infrastructure. For example, Pandora or some Spotify, right? How do they find what are the music that you'd like based on what you have listened and what you have rated? So we have such a data set here. Let me actually go and show you the.
You ready?
Oh, wait, 6. Yeah, go. There you go. So let me connect to my little cluster here. So this is my cluster. Now, what I'm going to use is a library called Mahout. Now, Mahout started from a project called Lucene, and it provides a bunch of algorithms. Not every one of the predictive analytics and data mining algorithms are there because they're just not parallelizable or somebody hasn't done the work yet. So I'm going to pick up this data set, which is called the EcoNest data set. It basically gives what people have listened to from a bunch of different sites where it was collected from. So this is the user ID, this is the song ID, and this is how many times they have listened. Now, for Mahout on Hadoop to process it, all of this needs to be integer. That is one of the constraints. So we use one of the Hadoop jobs to transform all these different columns into integers. And then we ran a Mahout job here to create the results. So the Mahout job here is we use collaborative filtering, essentially. Right? We use collaborative filtering, which is typically a recommendation engine. Now, we could have, if we had a much richer data set, we could have used something like a decision tree, classifier, which would have said that what are the entities of the song which are providing the inputs, whether they like it or not. So that's what initially Pandora, when they started off out of actually Spain, they started doing that. Now, let me actually show you the results of this job. I'm not going to run it because it again takes like 10 minutes to finish. So should have the output here. So that's the output, and let me do a cat on this. Yeah, typing is the hardest part up on the stage. So at this point, it's going and picking up for each user. What it's finding out here, if you look at this, is that for user 1, for song 1, what is the rating that they will provide on this song? So that's what it is giving me in this format. Now, it is now on the Azure Blob Store, the result of this job that I ran on the Hadoop cluster using the Mahout library. Now I can connect using something like Data Explorer, pull it down, and visualize it in a much prettier fashion.
That's the demonstration?
Yeah, it's not as pretty as, Hadoop is still an area where you work on command lines a lot. We are fixing it, we are making it much, much prettier, but it's not as pretty as doing it in analysis services.
Right, so that implies that there would be another phase. This would be an input to another process that would then go ahead, visualize, report, and so on.
Sure.
Okay, so that was data mining with Mahout. So we really come to the question that we were here that this session was based on, and that is, do you have big data? So actually, can we poll the audience at this point? Like, who here has learned from this session that there's potential with data that you have that you could start to realize today? Do we have at least 1, 2? Okay, we have at least 20 hands going up. So I think we can mark this to a degree of success, that this is what this session has been about, was to expose to you the potential of what you can do with that data and what you can achieve today with HD Insight.
Sure. So what we have seen is that most organizations traditionally just captured the outcome, the results of their business operations. They made a sale, they'll record the transaction which captured the sale. But what happened in the process of making the sale, they have just started capturing that. As people are walking with shopping carts around a store, those shopping carts have RFIDs, and they're actually capturing the path people are taking and the process of their decision of buying a particular product or not. So that is what we call the ambient data. Every organization has ambient data. And we can create much, much more valuable insights and thereby extract more value out of the data if we mine the ambient data. And so that's what we are saying. Now, with the Azure and SQL Server data platform, what we are trying to do is trying to provide a platform which can go through the arc of from small data to big data. Most big data projects in real life I've seen starts off from a single Excel file. Over time, as people find value, they gather more and more intellectual property and analysis and connecting to all kinds of data. They collect more data, and then it needs to become big data. But we don't need to break that cycle of innovation by saying, hey, you need to start learning a whole set of new things, and you can't work with the tools or the technologies that you are used to. So as a product manager, my goal is to provide you all the tools that you need for your journey, your data analysis journey. You find, combine, manage your data repositories, your big data or small data repositories. Then you form theories or hypothesize. And you then go through the iterative cycle of analyzing and refining that hypothesis. And then finally, once you have finalized that, you want to operationalize it. So the middle phase is where the data scientists come in, right? They go through this phase, or data analysts come in. Once they've done that, they operationalize it into dashboards, into other forms, which is easily consumable and which is where people can easily take decisions on. So at the end of the day, we want to make our data platform easy. It doesn't need to be really hard. It doesn't need to be the command line with scrolling text, right? You need to still be able to consume with tools which you are familiar with. They still need to be extremely powerful. What Peter showed with analysis, data mining capability in analysis services is very sophisticated, right? It's very powerful. We are bringing that to big data as well. And it needs to be complete. If one core piece of the data platform is missing and your journey to the data insight is broken, it's of no use. Starting from discovery, where we showed with Data Explorer, to insight, that whole journey needs to be complete. With that, back to Peter.
So where do you go from here? So we'll leave you with some resources. The Microsoft Big Data homepage will take you to current information and where the product is and where it's going. There's the Windows Azure HD Insight site. And I thought some interesting blog articles here as well, like the last one. How can you use the familiar BI tools that you're using today and continue to use them whether the data source is big data or not? From a point of view of related content, there are a number of sessions this week here at TechEd in Europe. So big data analytics with Excel is tomorrow. It's very much focused on two topics, big data and how a self-service approach could be used to produce data models and reporting by using Excel. On Thursday, I've got another session on data mining. It's got nothing to do with big data, but if you wanted to learn a little more about association analysis and how you could update an e-commerce web application to drive consumer or meet consumer need by providing recommendations, that's just one demonstration that comes in on Thursday. And then enriching big data for analysis, again on Friday, and data management with HD Insight. That enriching big data for analysis is a level 400, so it's a pretty in-depth deep dive into what you can achieve to get the most out of preparing and processing and querying your data. Standard resources, Channel 9, TechNet, MSDN, Learning. I'll take this moment to just emphasize how important it is for us that you evaluate these sessions. It really helps us understand whether we're meeting your requirements. It helps us prepare for future events as well. So the QR code here can help you fast track to get to the evaluation, and your feedback is very much welcomed. So at this stage, we've arrived at the end of the session. We've got about 4.3 minutes left. We haven't provided you any opportunity for questions during the session, and so now would be a great time if you've got questions that we can attend to them. Absolutely. Are there any questions? We must have done a terrific job.
I think so.
So it's a thank you very much for your time and attendance. We do hope you get good value from this session, and thank you.
Thank you so much.